Kia ora mai te whānau. Nau mahara mai whakatau mai ki tēnei wānanga, ka whakapāho atu au ki a koutou mai tēnei kokona tāhua te motu, a tauranga moana, mai te kura iwi nei a te wharekura maua. Ko te mihi tuatahi ki a rātou, ngā mate me ngā mamai wanganui a tātou. Kia maumahara ti a rātou, ko ngā whanaunga me ngā piringa karanga maha ko e hinga ki tua o te rai. Haere atu rā ki hoai ki pāmamao, ko whāriki hea rātou ngā huarahi o te mātauranga, hei hikoinga mā tātou ngā uri. Huri no oku mihi ki a koutou, ki a tātou te humoroa, ki a koutou ngā kāia ko te motu. Ahakoa ngā mahi taumaha kei te kura, ka pakanga tonu koutou, ka whai huarahi hau, ka ngana koutou ki a puawai te ihi me te wehe o ngā tauira. Nō reira kei te mihi. Ko Greg Scrivin tōku ingoa, ngā te Pākehā te iwi, ko Dominion Mana ko Oriental ngā waka I kawe mai o ku tupuna ki tēnei motu. Kia timata au ki te karakia. Nō reira e tau nei ki rungi a tātou katoa te wairua ngā matua tipuna. Nā rātou I whakatakoto te ara hei hikoinga mā tātou ngā uri. Kia ngākau nui ki te hāpai a tātou mahi katoa I roto te pono te tika te maramatanga me te aroha no te hiki te. Ko ia rā I rongo whakaere ki runga tūturu whakamaua kia tīna, haumie, huie, tāiki e. Nā, ko te ingoa tēnei whakāturanga, bring coding into your classroom. Now, it's not as if I'm an expert on all of the stuff in this presentation. I have been teaching coding for several years now, but I've just been researching hard out a lot of the free stuff out there in order to encourage you, kaiako, to not be afraid and to try this in your classroom. Aha koa reo rua, aha koa reo Māori katoa tō kura. Kei te pai, I got your back. Now, I'd like to shout out before I start to the people that really helped me in the Kia Taka 2 movement to get started into this research. I'm talking about Rosalie, Te Whainoa, Malcolm Clark, Tim Bell, Tim Hartford, and many others who I've interviewed along the way of collating all these resources. Thank you guys so much. Nāku te rauru, nau te rauru ka ora tonu nā kai ko te motu nei. So let's get into it. The obligatory PowerPoint clip art. All pictures with a drop shadow have a link embedded in them, so I've tried to make this presentation user-friendly. Anything with a drop shadow, you can click on it to get resources. Why teach using coding? The biggest barrier to teaching using coding is the misconception that it's another skill that you have to teach, and the misconception that the kaiako must be an expert in order to teach it. It's not true. Coding is simply a tool that can be leveraged to teach your subject in a more powerful and creative way than using worksheets. So basically, you don't have to be the expert. You set your kids loose on it, and their creativity shines through. So you have a little catchphrase. Students shouldn't be just learning to code. They should be using coding to learn. Great for cross-curricular integration, critical thinking, storytelling, retelling, problem-solving, teamwork, learning to be creators in a digital world. Thanks, Tim Bell. So this was sent out a couple of years ago. Some of you might have seen it. It's now compulsory for kura to be teaching hangaro. And is your school ready? Maybe not, which is why you're watching this. 4 steps, not yet started, now underway, 2020 ready and leading and innovating. This here is a link to the website, which explains all this stuff a bit more. So I just grabbed a bit of stuff out of the level 4 one. You're teaching technology learning, so it's cross-curricular. So this is something to aim for, basically. You talk to your students, they feel comfortable using the vocabulary, but basically it's not too hard for you guys to get to this stage if you follow some of the advice that you're getting in this presentation. Growth mindset. I don't know how to code yet. Add on that magic word yet onto your sentences. Tips for teaching coding in your classroom. Learn along with your students. Help students become experts. That's a good one because there's always those 3 or 4 little sharpies in your class that can learn much faster than you can. Let students' own interests drive their learning. Very important. Encourage them to become producers of digital content, not just consumers. So why play games when you can make your own games? Why watch videos when you can make your own videos? This slide is all about the hangaro curriculum. So these links here take you back to the TKI page. I've dug a lot of gems out of TKI in doing my research for this presentation. So follow these links to get the background to the curriculum. 2 main strands we're talking about. computational thinking and designing and developing digital outcomes. These are 2 of the 9 strands in Hangaro. So these 2 relate to Hangaro Matahiko specifically. In Māori, in the Te Marautanga o Te Roa curriculum, they're called Whakaaro Rorohiko and Te Tangata Me Te Rorohiko. But they kind of align to these explanations here. So computational thinking. What is computational thinking? A problem-solving process. So what I did here is in my research, I found on American websites and New Zealand ones a variety of explanations of computational thinking. And I've tried to kind of summarize it in language that you'll understand. And there's a lot of big words on this slide, right? This is the official outline of computational thinking. So I've tried to break it down for you guys. So this link to the BBC website is quite nice. It gives you a little breakdown. For example, if you're planning with your friends to meet somewhere you've never been before, you'd probably plan your route before you step out of your house. You'd be texting each other, you'd consider the routes available, which one's best, the shortest, quickest, which one goes past your favorite shop, and follow your step-by-step directions to get there. So the planning of that part with your friends is like computational thinking. So you're breaking down what you could do, where you could go, the various objectives that you might want to go, who wants to go where, to what shop, how much money have you got, what the weather's doing, how much time do you have. So breaking the problem down like that is called decomposition. Only the relevant details are focused on, weather and location that you want to go, abstraction, knowledge of previous times you've been out and previous shops you've been to, pattern recognition, and then working out a step-by-step plan of action is writing an algorithm. This link here takes you to a whole bunch of videos from Tim Bell and others about what computational thinking is. This one here, I have decoded the progress outcomes. So this document is in your little resource pack. So basically here is the tech speak of what the progress outcomes are, and here is a nice simple English translation of what that means. So you can look at computational thinking outcomes 1 to 5, tahi rua toru wha rima, and basically figure out in plain English what the students are supposed to be able to do at each level. Designing and developing digital outcomes. And this is the second part of Hangaro Matahiko, and digital outcome can be anything from animations, games, artwork, spreadsheet, database, website, app, program, any electronic digital outcome that the student has made to solve a problem. So ahua orite ki te engineering design process. Tauira can find a problem to solve with their digital outcome, or they can find a person that would like something made for them. So they interview the stakeholder, they do their design, they feedback, they show it, they can then tweak it based on their feedback. So they can go through several iterations, several design cycles of improving to get their finished product. And then they can write about what the process they went through. Flash name for it is end user experience, which you need to take into consideration for your digital outcome. And again, back on this page here, I've also included the DDDO progress decoded again. Here's the official text, and here's what they actually should be able to do at level 1, 2, and 3. So where do we start on your journey? So this is my basic recommendation. You don't have to follow this. This is just after picking lots of people's brains. Start with Computer Science Unplugged, some simple games or activities to introduce Tauira to computational thinking before you get onto devices, which is what Unplugged means. And then moving into block-based coding. Scratch is a great place to start for your classes, and Scratch can be extended into robots, makey's microbits, as I'll show you, and even machine learning. It translates well into Python and JavaScript as well, moving on to script-based coding, and then into senior NCA computer science, and then basically into jobs like programming, game design, Weta Workshop, massive growth boom industry at the moment, and a lot of future jobs are going to be in this area. So where do we start? CS Unplugged from the University of Canterbury, the Department of Fun Stuff they call themselves, brilliant work. Here is their website, CS Unplugged, and this is just gold for computational thinking resources. That's this link up here. Great place to start. Inspired learning with everyday items. He kite tēnei, or ideas for demonstrating sorting algorithms. This has been translated into Māori as well. They're all in reo, which is awesome, save you a bit of time. And then another example activity, find the longest route through this maze following the rule here. So you've done a bunch of unplugged activities, now you're ready to move on to Scratch. I've been teaching Scratch for years and years and years, and you always run around the classroom putting out fires, but you save your sanity big time by having a help sheet with some blocks printed on it for the tauira to look at, so they don't have to ask you every 5 seconds, what do I do now? And as I've been researching around, I've found several ways that you could possibly introduce Scratch to your classes and gain more confidence with it yourself. This document, The Basics of Scratch, was called Troubleshooting with Scratch. I've just called it The Basics of Scratch because it gives you just a very good go through of how the menus work, where to find the pictures, how to get rid of the characters called sprites, how to navigate around the interface. So just a very good introduction. And then you can just go to the Scratch website and click on Start Tutorials. Boom. You can just click on Tutorials up here, and the students can start with a simple tutorial like that. Another way to start is to draw a square. So you can start on paper, and Pears list the steps to tell a computer to draw a square, and then you put this file into their Google Drives. Here's the blocks needed to draw a square in Scratch, and the students can just drag them around into they can just drag them together and try and figure out what works just by experimentation. Just let them try, and if it doesn't work, it's called a bug. Finding a bug is exciting. It means that, oh, now I've got a challenge. So making slight improvements and retesting your program is called using an iterative approach. So iterations are like when you try again and again and you tweak it and you try it again. That is like the key process in programming. Always have an extension activity for the quick ones. Can you make the square different sizes, different colors, a hexagon? 10 block style challenges, I'll describe those in a minute, and provide a printed help sheets with block scripts for Toto to follow. So in our Ki Te Rauimi here, scratch cards. Simple little activities with scripts to help introduce this to your students. Debugging. Ki te hara mai te taura ki a koe. Mātua kare pai tēnei. Ka pātai atu ki a ia. What did you expect to happen? What did happen when you ran the program? What does your code say? Some good focusing questions to help your tauira debug their program. Now, Scratch in Māori. Kei te mōhio au kei te ūkaha e te hio koutou kura ki te reo Māori. Hore kau he reo Pākehā. Hare te tino raru tēnei, ka huri to Scratch ki te reo Māori. Thanks to Greg Ford translating it all for us. Just click on the globe there. You can whakamāori the whole thing. Easy peasy, Māori. Just to help you get your head around the Māori scripts, I spent half an hour clipping the Māori scripts and then the Pākehā scripts and putting them beside each other. You can print this resource out and quickly and easily figure out what the Māori script is trying to say. There's 4 pages of them. You can print them, laminate them if you like. And on the last page, he kuputaka, hei awhine i a koutou. And that really makes it a little bit more user-friendly to do it all in Māori, but certainly easy peasy. And at any time, you can flick it back to English and just check you have got it sorted. This link here is to a list of Māori words that I have researched. Ipurangi, social medias, internet, Word documents, Excel, PowerPoint, and then a whole bunch of kupu for coding, and then parts of a computer. So just a really great collection of kupu I've printed on my wall, and they help us kōrero Māori i roto i te karahi. Now on this next slide is another way to get into Scratch. This creative computing curriculum is a free resource. It is brilliant. It really does scaffold the whole thing. It comes with a learner workbook here. If you click on edit, it gives you a massive document with reflections and instruction sheets for each unit. In Google Docs, you can post this to Google Classroom and the students could work through it on their devices. Then you have Getting started, introducing Scratch, making a design journal, exploring the blocks. There's our 10 blocks challenges that I mentioned. So the students get 10 blocks to make a project with. Basic animations. Build a band, use the music and dance features of Scratch. Telling stories. I'd love to see Te Reo Māori teachers using Scratch in their classes to tell Paki Waitara or Kiwaha. I asked Matua Aramaho, my head of Māori, for a list of Kiwaha, and this is a great little basic list of Kiwaha. I'm going to use one of these to make a Scratch animation to show you how it goes. Let's choose Kua Pakaru Te Pūkoro. Okay, so I've opened up a new tab of Scratch. I've logged in so I can save my work. And this sprite here is the default cat sprite. I don't really want to use that, a bit boring, so I'm going to click on the rubbish bin to get rid of that. I want to use myself actually in this Kiwaha video. So what I've done is I've got one of my tauira to take some photos of myself in different poses. And I'm going to make a walk cycle in Scratch using this. Just using my phone. If you're working on Chromebooks, the kids could just use the Chromebook camera or whatever devices you've got. I'll have a camera. Take some photos. Now I don't want to have all this background around me in my animation. It looks dumb. So we're going to use a trick called Remove BG. And on this next slide here, you'll see a link to Remove BG. So open up the website, take your picture, and just drag it on to the website. Straight away it removes the picture, then we can edit it. You can erase and restore bits that you don't want. Get rid of some lockdown puku there. Ka pai. Download. Job done. Go back to our Scratch tab now and upload sprite. Let's start with walk 1. Now once we have that one sprite there, the rest of the pictures of me are going to just be costumes for the sprite. I don't want to make 4 separate sprites with the 4 walk cycles. I'm just going to add costumes. So here is my add costume tab. Walk 2, walk 3, and now the remove BG only exports a preview size, but it's perfect for Scratch. It doesn't have to be high resolution. And walk 4. So now I've got my 4 costumes that make up my walk cycle. At the moment they're not centered, so let's just quickly convert them to vector. And now we can drag them and snap the center of the sprite to that, convert to vector, snap the center of the sprite to the middle bit there. Now we're ready to program some code. So here we are, I've made this script block here. When green flag clicked, go to 205 minus 83, which is my coordinate. Switch costume to, I've chosen the costume that I want to start on, and think a message for 1 second, and then I want to take 15 steps, so I've put repeat 15 loop, move 10 steps, next costume, and then to slow it down a little bit, I've dragged the wait 1 second out and I've changed it to 0.1 seconds. And let's see what happens now when I click the green flag. Okay, so I'm a little bit big at the moment. I need to change my size. And I need a backdrop. These are the default backdrops, or you can import your own. Okay, perfect. There's my theatre. Let's try it again now. Perfect. Okay, let's find myself a friend. This time I'm going to choose a sprite from the library. Now when you hover over the sprites, you notice that some of them have animated costume movement already. I'm going to choose one with the walk cycle. I can move her over here. Now, I want her to move back towards me, so I'm going to make her point in direction. Instead of 90 is to the right, I'm going to change it to the left, minus 90, and I'm going to make her move back towards me. Now you notice that she moves upside down. So to fix that, to fix sprites going upside down when you move to the left, you just have to click on the direction. This option here makes them go upside down. This one here forces them to stay left and right. This one here forces them to stay right. So I'm going to choose the middle one, stay left and right. And now when she walks towards me, she's the right way up.
And I'm going to go next costume as well, so I can see her walk cycle. Bingo, there we go. She's a bit of a giant at the moment, so again, I'll adjust her size. I'll drag her over here. So how do I make her appear? Under looks, we've got show and hide. And when the green flag is clicked, I want her to not be visible. And I want her to start on the side there. Now, how do I make her appear when I've walked to the middle there? I use broadcast. So when I've walked to the middle, I broadcast message 1. I'm going to change that to mai pānui. So ka whakapāho atu tēnei pānui ki ngā sprites katoa. So when one sprite broadcasts something, all the other sprites can hear it. So when I go back to Avery's code, when I receive ko tai mai, point in direction 90, I'm going to show myself, point in direction 90, move 10 steps. Now that's only one step, remember, so I want to get my repeat loop again and take 10 steps. Let's try that. That's not far enough, and she's moving too fast, so let's go 20 steps. And we're going to put wait 1 second and then to slow it down. Now I encourage the tauira to record their own voices for these animations, so let's record a new sound. Record. Kia ora matua, he tikiti tau. You can crop the recording. Kia ora matua, he tikiti tau. Save it. Call it. Kia ora. Okay, I've built this extra script. Set pitch effect to 30 to make it a bit higher. Start sound kia ora and say the message as well for 2 seconds. Wait 1 second and then broadcast kia ora. And then back on my sprite, when I receive kia ora, I start my sound and I say it in a speech bubble as well. So let's just try that. So I can stick that on the end of my walk cycle, and now we should have a completed animation.
Kia ora matua, he tikiti tau.
Kao, kua pakaru te pūkoro. So this is how you build up an animation for Te Reo Māori, Social Studies, Te Reo Pākehā, Pūtaiao, He Ahata Kaupapa, for it in Scratch. Tauira might want to put their own animal in. Some animals here. On our presentation, the link to Switch Zoo. Click play now. Tauira have a lot of fun making their own animals. Once you've got a good one, take a screenshot, go back to Remove BG, and there it is, download your sprite. So on this next slide, we have another fantastic entry point into Scratch. You can learn Scratch by doing the maths curriculum, coordinate geometry and shapes. An amazing resource. It's got script blocks, it's got challenges, differentiation built in. Highly recommended. Machine learning for Scratch, you can make use of machine learning AI scripts on that website. Microbits. Now we're getting into Scratch extensions. We click on this little box down the bottom of the code blocks and get into our extension code blocks. So drawing with a pen, playing musical instruments, makeys, microbits, Lego Mindstorms, Lego Boost. So really Scratch has been updated constantly to make use of this new hardware. And microbits are only around $30 each. They're very versatile. If we look at the website, it has tutorials, projects, games, fashion, music. You can put it in your clothes. You can attach it to various electronics, tools, and it's very good for transitioning from block-based coding into JavaScript as well when you get into your program. So you can download the program to your microbit. It will do exactly the same as what this virtual one is doing. These buttons work as well. You can change it to JavaScript or Python, just like that. and see what the code looks like as script. So it's brilliant for transitioning from blocks into script. Makey is a little digital board that plugs into your laptop, and you can use anything that conducts electricity as a keyboard. So if we have a look at the promo video, you can use fruit, Play-Doh, and even buckets of water. Anything that conducts electricity. So Makeys are a lot of fun. Microsoft MakeCode Arcade, a great little simulated Game Boy. You can use block-based coding to build games. Plenty of tutorials there. Game Fruit, fantastic New Zealand-made resource. New Zealand-based artwork, sprites, storylines. So on the website, click Start Creating, log in, pick a tutorial. Here it comes over here. Just follow the instructions on the right-hand side pane here. On my website, I also have a Game Fruit page under Digitech, which has tutorials and walkthroughs. Pencil Code is a block-based programming language that one computer science educator suggested. This is what it looks like. You have a wee turtle that can draw shapes, following instructions. So this is a whole other programming ecosystem to try. There's a link here to a Lady Macbeth chatbot, which is quite fun, which the tauira can adapt to their own needs. When should tauira move from Scratch blocks to scripted code, JavaScript and Python? There's no set time really. One educator suggested setting a challenge. For example, can you design a maths game for a primary tauira to add 2 random numbers up to 10? And here's a link to the project that they suggested the student should be able to create. You'll find tauira have a very wide variety of abilities, and some of them will be ready to move to scripted code fast, and other ones will stay with blocks a long time. Ditta. So sign up to our professional user group, sign up to the general and multi-medium. When you sign up, click on your profile picture, click profile settings, and then your email notifications. Default is instantly, which means you get an email for every single comment that anyone makes. Change it to daily. That's much more manageable. You get a daily summary in your inbox. So they have great resources on a wide range of platforms. Ditta has a lending library. If you click on this link here, you can book Bbots, Makeys, and Microbits 2 terms in advance, and they send them to your school for no charge. Code Club for Teachers, fantastic resource. Scratch, Māori Chatbot, Matariki, Digital Gardening, all New Zealand resources, digital storytelling, Pepeha and Scratch. Kia Taka 2 course. Kia Taka 2 was a 3-year project designed to help kaiako get ready for implementing Hangaro Matahiko. All of the resources have been rescued and are now on the Core Ed website. Again, toolkits for Māori medium, toolkits for English medium. The whole resource pack is there. On the next few pages, I just have some really cool stuff that I've found in my research and I've used it myself. Clap motion animation. And I've put a lot of links to these on my website under the Digitech menu. Microsoft Education Edition has block-based coding built into it. Every single student in New Zealand has a subscription to Minecraft. Push C for Code Builder. And now there's a whole bunch of tutorials here. You can have superpower, mega jump. You can make 1,000 TNTs appear. You can make a lava tower, tauira lava, blocks coding and Python coding. The only problem, of course, doesn't run on Chromebooks. Minecraft also has fantastic maths and science, history, and even computer science and coding curriculums built into it. If you click on lessons, it's all there. Brilliant. Sculpt GL. Nice way to make whakairo. Tauira can have a play with that. There's various sculpting brushes and tools. App Inventor 2. Tauira can use block-based coding to write an app for an Android phone, make $1 million. Tinkercad, fantastic software for designing stuff and 3D printing. Probably one of the better options for for Kaido Māori as well. Grok Learning, super slick Australian website, which is subscription based, but Kaiako can access the whole site for free, including all the tutorials, training courses, and teaching materials. Koreutu. Code.org classroom feature. You can log your classes into code.org and they can work at their own pace through the course. Raspberry Pi projects page. Absolutely fantastic. A zillion projects. Pick any software you want. Scratch projects, Python projects, App Inventor, Blender. Tons of ideas there. Instructables, another huge repository of lesson ideas. Similar to Raspberry Pi projects. Just tons of project ideas. Other resources. Okay, this link here is from the Computer Science for High Schools conference. If you look on the 2017, 2018, 2019 years under resources, there's some gems in here that other kaiako have used in their teaching practice. Absolute gems. TKI, of course. CodeWoff, new initiative from the University of Canterbury for tauira and kaiako to practice their coding. They're working on expanding this right now. Just thought I'd chuck in BlueKit at the end. It's the latest evolution of Kahoot quizzes. Give it a go, especially the factory minigame. And last but not least, I thought I'd put a word in for Recycle a Device. Many of your kura out there do not have many good devices, laptops. Recycle a Device is set up as a non-profit organisation through several charities. Big companies like Spark donate their laptops to RAD when they upgrade them. They get professionally wiped and sent to kura, and tauira fix them up, replace the batteries and install Windows 10. All the information's in the drive. Get in touch with me if you want to know more about this program. We're looking to onboard more wharekura over the next few years. So, have a go. Kaua mataku. Encourage your students to awhi each other. Keep in touch with me.
Hioia no, hei kōrero whakakapi. Kia ora mō tō mātaki mai taku whakāturanga te rānei, ko te tumanako. Even you experienced kaiako that have been teaching coding for years have got some pearls of wisdom out of this presentation and all my research. And you newbie kaiako that are not sure where to start, but are keen to get started and bring coding into your classroom, I really hope I've scaffolded it nicely for you and provided lots of roemi. So download the roemi out of the drive. Check out my website for more ideas. Give it a go. You have all the support of DITA and other government agencies helping you out. So kia kaha, kia maia, kaua mataku, kia ora mai tātou, kia pai te rā.